Hi, everyone. Thank you for joining us today. My name is Michaela McShane, and it is my privilege to welcome you to the T2U Innovation Series. T2U stands for Technology Transfer University, an initiative that helps NASA build relationships with innovative colleges and universities while introducing cutting-edge NASA-developed technology to students. The series focuses on firsthand experience and best practices from distinguished instructors at colleges and universities around the country. These educators have valuable perspectives about the educational benefit of bringing NASA-developed technology into the classroom. Today, we will hear from from Gregory Mihalik, a professor of practice at Georgia Institute of Technology, who teaches technology entrepreneurship at the College of Engineering and School of Electrical and Computer Engineering. As a quick note before we get started, all audience microphones will be muted, so please type your questions in the chat box in the bottom right-hand corner of your screen, and we will answer those in real time at the end during the Q&A session. So questions throughout while Mr. Mihalik is speaking, and then we will address those at the end. All right, so our speaker today teaches a course on evidence-based entrepreneurship skills and principles benefiting students who are launching a business or pursuing careers in technology and innovation-driven campuses at Georgia Institute of Technology. The course is designed to be an experiential, team project-based program that educates and develops future engineers and entrepreneurs through discovery and real-world experience. Mr. Mihalik coaches and mentors student startups during the summer. He is a CreateX coach. CreateX is a Georgia Tech initiative to install entrepreneurial confidence in students and empower them to launch successful startups. The CreateX launch element consists of a program for students and alumni who want to launch their projects from idea stage and beyond into fully functional, viable startups. And with that, I will let Mr. Mihalik tell you a little bit about how he incorporates NASA-developed technology into his classroom.
Thank you, Michaela. Let me share my screen here. Can you all see that?
Yes, looks good.
All right, perfect. Thank you. Well, thank you for that introduction, Michaela, and I appreciate the opportunity to share what we're doing at Georgia Tech with your audience today. What I'd like to cover today is a little more about my background, because I think it'll give you some sense of where I'm coming from when I teach the course and some of the things that we're trying to teach our students there. I'll give you a little overview of the School of Electrical and Computer Engineering at Georgia Tech. I will talk a little more about CreateX, then introduce you to my course, the course that we developed over several years here, and how we integrate T2U into that course, end up with some examples and lessons learned for today. So what I thought was pretty cool is I usually do this introduction to my class, but as I'm doing this, I recognize that the very first job I had coming out of school was a research scientist for the Department of Energy. And I was blessed to be working with some incredible coworkers. My boss was Dr. Rock Monchamp, who had gotten his PhD from MIT, had grown up through his and done his thesis on making and synthesizing materials that had never been made before. So I had an opportunity to work with him to learn all about material science and grow crystals under the auspices of projects for the Department of Energy. We worked for a company called EG&G Energy Measurements, and they ran and were the sole source provider for the Department of Energy in several of their contracts. At the facility I worked at, besides growing the crystals with rock, I worked with a gentleman by the name of Dr. Ludwig Vandenberg. And the reason I point this out is not only was Ludwig an astronaut, but we grew crystals in space as part of his project. That crystal shown in the bottom was an ampule that was put in the space shuttle. And the team at our facility got to support that operation when they launched, and we got to work with Ludwig. And then the other reason that I think it's noteworthy is after we closed our facility there, Dr. Vandenberg went on to start a company to commercialize the growth of that crystal. So I got firsthand experience of what it's like to do research and then commercialize it. I had actually interviewed with him and his company that he started over in Florida, and he spearheaded it. And along that journey, I was also introduced to some other scientists, which was my first foray into a startup. I worked with a gentleman by the name of Dr. Nathan Skinner, who was an adhesive scientist. He was a successful entrepreneur who started a first company, and he and I had an idea to work on a startup that purified water. At the time, I was an avid hiker, and I enjoyed going into doing hiking with my friends. And it was a very much of a pain point for us to do water purification because we would use iodine or chlorine tablets as the lightest weight, but it tasted awful. So Dr. Nate Skinner was able to successfully come up with a two-step process to purify water and remove the taste. But when I first started and tried to launch that business, I found myself fumbling around. I talked to the SBA and was told make some business plans. And I did a lot of business plan work, but what I never did was talk to customers. So my first foray into my idea for a startup was an epic failure. And I love telling that story to the students because it wasn't that our product didn't work, because you can go online today in Amazon, REI, anything, and you can see a two-step purification process that's sold out there. So it didn't fail because it was a bad idea. It failed because I never went out and talked to customers. And so I love sharing that story and saying, hey, we as engineers can have solutions, but unless we're out there sharing those solutions and talking to our customers, it doesn't get to go anywhere. So that was my first journey into my professional career. And I spent between 5 and 10 years doing research. I then spent the next 25 years of my career working for a variety of different corporations and industries. So I worked my way from a process engineer to a C-level executive, running some businesses. Spent most of my time growing silicon crystals, working in the solar industry. But I worked for some amazing companies and learned the value of how to execute and grow a business. So I understand very much how a business works, how a successful business looks, and what drives business. But all through that journey, I never lost my desire to do a startup. So I started my career with an interest in that. And then towards the latter portion of my career, I had an opportunity to join a startup that came out of Georgia Tech. And I had grown up, interestingly enough, as a background, I had grown up in Clemson, South Carolina. I went to high school a couple hours from Georgia Tech. So it was an opportunity to come back to Georgia and come back into Atlanta and join a startup called Suniva. And this young man here, Dr. Ajit Rahati, is our chief technical officer. He's also a faculty member in the School of ECE who I get the pleasure to work with. But it was his research in his research lab at DOE that was commercialized, and joined the company to help grow the business. So after we ended up, and that's the reason I'm back here at Georgia Tech, I got an opportunity to work with Ajit. And then following that career, I had an opportunity and thought about what I would like to do with the rest of my, with the fourth portion of my career, and I decided to teach. I actually started teaching in high school, where I taught engineering to high school students at one of the state's largest high schools at the time. And I really enjoyed teaching, and the faculty and the teachers that I worked with were amazing. They taught me the value of experiential learning and what it takes to really connect with students. While I was doing that, I was lecturing at North Georgia and also volunteering time at our summer program at Georgia Tech for startups called CreateX. And that led to an opportunity to join Georgia Tech as a professor of the practice. So I have a very unusual route into academia, but what I like to share with my students is, if you want to do research and work for a government entity, work for a government, I've got some experience and can help you there. If you want to do industry, done that. And then if you want to do a startup, I've got a lot of experience with that. And then as I'm doing it here in the fourth portion is doing some academia work. And a lot of our students, when you ask them what the outcome they would like when they finish our course, and I teach, and I'll get into that in a little bit, but I teach a master's course. Many of them say they want to work in industry. So just want to let you understand some of the directions that I do. And as an employee in the summer for CreateX, we get to launch startups. I'll talk a little more about CreateX, but some of those CreateX companies are listed here. These are some photos from our demo day, which is usually well attended from both students and the public. Just a brief overview of ECE. It's one of the largest producers. We at Georgia Tech in ECE are one of the largest producers of electrical computers engineers in the world. Got some over 1,200 undergraduate students, around 1,500 masters and PhD students. Schools ranked very high, and it's one of the top 1 or 2 public universities in the U.S. So Georgia Tech does well, and ECE specifically also does a lot of research. We've collected a lot of money for annual research, where We have a variety of different areas that we focus on. We have a lot of collaborative efforts with corporations out there. I'm just mentioning a few here. We've worked with NVIDIA to create an AI makerspace, working with Apple on their new Silicon Initiative, and we do some work with Texas Instruments to have students design analog chips. These are just a few of the collaborative efforts in some of our research labs. But that's a very quick and a broad overview of ECE that we have. Let me do the same thing for CreateX, so you have an understanding of the ecosystem that is available at Georgia Tech to support our budding entrepreneurs that come out of the program. CreateX was started about 10 years ago with the mission to instill entrepreneurial confidence in our students and empower them to launch real startups. So that was the mission statement. And if you look at the specific goals, Georgia Tech would like to be the #1 startup campus in the country. We'd like 100% of our students engaged or touched, both undergraduate and graduate students, by the concepts of entrepreneurship. And we're looking to, physically encourage and start over 300 student startups a year. Let me give you some of the statistics on what we've been able to achieve in the past decade at Georgia Tech. So right now, through the CreateX program, they've supported over 650 startup launches. There's been over 17,000 students that have engaged in the program. We have a lot of very successful startups that have come out of the program, 8 founders of 30 Under Club. Here's some more statistics, and you can see how the growth trajectory has been pretty solid. And it's just, it's a testament to the ecosystem that exists at Georgia Tech. And I mentioned that I had done a startup called Suniva. We actually came out of Georgia Tech and used some of the ecosystem and support and accelerator programs that are around the university to support the startups. A little more detail on the program. As a startup, you need to have one student or alumni or faculty member on your team, but you can bring in other members from other universities or other places around the world. And here are some other university students that have joined some of the Startup Here programs. And here's a quick summary of the program itself. In the summer, it's a 12-week program with the goal of getting customer discovery done, validating our business thesis, and really pushing customer discovery. Every one of our teams is awarded a $5K seed funding and $150K in like resources for legal, accounting, and other services they can use to do their discovery and push and build prototypes. And it culminates at the end of the summer with a demo day. And those were some of the pictures I had showed you earlier, where we get some 1,500 to 3,000 attendees here at Georgia Tech. These are just a few of the very successful programs or companies that have come out of the program. I'm not going to elaborate on a lot of them, but suffice it to say that over a decade, there's been a lot of very profitable companies that came out. But there's also a lot of companies that have made a lot of profit, but are really successful. And as part of what I get to do at Georgia Tech is talk to founders that may not have had the success they have here, but they all appreciate the fact that they learned a lot throughout the summer and they truly got their entrepreneurial confidence. And many of them say that they may come back someday and do a startup. So that's the CreateX program that we have at Georgia Tech. And so let me kind of then turn my attention here to share what we're doing in our class. In around 2017, Dr. Badi and Siva, who were one of the founders of the CreateX program, launched this class within the master's program in electrical and computer engineering at Georgia Tech. And they identified a need for our students to get a little more education in some of the practical skills and entrepreneurial skills that make them successful in some of the businesses that they will then go work for. So we launched the program in 2017 with the goal of educating over 300 master students a year. And today we're hitting that number and we're actually achieving it in a bigger scale. We're doing around 450 students. We deliver this course across 4 different platforms. We have co-instructors in the different locations that run the program on the ground. Talk a little more about what it is that we do. But for a master's degree, the Technology Entrepreneurship course that I teach is a mandatory course. So it's a 3-credit course, and it's 3 of the 30 required courses. So my job is to complement the outstanding technical education these students get here at Georgia Tech and provide them a foundational principle in entrepreneurship, and we give them some very practical experience and activities to do that here at Georgia Tech. So a little more on the class and how we basically set up the class. So as I mentioned, it's a 3 credit class, and we structure it in a way that we deliver a 1-hour lecture to the students, and it's very much, because of the numbers, very much a one-way. We have some dialogue engagement, but with the numbers we have, it's very much a one-way street there. And then we have a 2-hour studio where we flip it around, where we have the students demonstrating to us the concepts and ideas that we talked about in the lecture. And then we reward them with 3 hours of unsupervised lab, and that's to give them credit for going outside of the classroom to actually demonstrate in the real world some customer discovery and activities. So the idea is that students share with us what they've done outside of the classroom and demonstrate the topics that we're talking about in the studio. So we have studio sessions that last about 2 hours, where we have team-based activities and individual activities where students share with us what they do. As Michaela mentioned, the course teaches evidence-based entrepreneurship skills. So we like to emphasize the fact that we're detectives going out there and being scientists. We're proving or disproving thesis and hypotheses that are supporting our business idea and our business model. We heavily leverage Osterwalder's concepts and tools in the class to demonstrate some of these concepts. And the purpose of the course, as I mentioned, is most of these students are going to pursue jobs in industry. The majority of them will. When we ask them, how many of you are interested in doing a startup, there's a very small percentage that are today interested in pursuing startups. However, if you ask them after a few years or after many years, we get about 80 or 90% of the students saying, yeah, after some period of time, I'd love to come and do a startup. And there's only a small fraction, maybe 10 to 20%, that say, no, that's not for me. But we understand that. So we designed the course to teach them and to provide them entrepreneurial confidence, to understand the knowledge, the vocabulary, and the skills necessary for an entrepreneurship role or an intrapreneurial role at some of these high-tech companies that these students will work for. And when we ask our students, what companies y'all want to work for, as you can imagine, they're saying Google, NVIDIA, Apple, NASA, many of the high-tech companies that are out there today. These students want to work for there, and in fact, they do. So one of the very coolest things we get to do is in our course, we partner with our career services folks who are corporate relations team. And we talk to our students. We ask each individual what their desired outcome is. And as I mentioned, there are 4 different typical pathways our students approach. But many times, many of these students have achieved their dreams. They've got a job with Apple, or they've got a job with NVIDIA. So it's very exciting to see that fulfillment for our students. And it's also very inspiring for their peers, right? They have a chance to network and get to know and get to work with many of their co-students who are going to be working at these institutions. So that's the class that we do. I'll talk a little bit more how we integrate NASA into the program here next. So for about 3 years now, we've integrated T2U into our program. In our course, we run different projects throughout the studio. One of the projects we run is based upon the NASA patent portfolio. We basically offer that link right there, which will take you to the patents, to our students, and tell them or ask them to say, come up with, as a team, come up with an idea, and we're going to do some customer discovery and testing around that idea to prove some stuff out, and then they'll come back and report to the class. So they will actually come out, leverage the patent portfolio, and come up with an idea. And I know some previous webinars, some of the teachers have talked about how they manage the patent portfolio. If you look back and you look at the slide of the research topical areas that we do within ECE, you'll find that very much overlaps with many of the patent topics that are in NASA. So it's very reasonable for me to expect our students to understand and appreciate how to apply some of these patents. And they do, as a general rule, they do a fantastic job of coming up with ideas. So they'll use the patents, they'll come up with an idea, they'll then share that idea, get some feedback in the class, we'll move on and do another project, but we then come back at around the midway point, which happens to be about this portion in our semester, where for our final project push, teams get to select what project they would like to work on. So we don't force that project selection on the teams. And what we find is that about a third of our teams in our classrooms, we typically have somewhere between 4 to 6 teams in each one of our studios. So we're running around 30 to 40 projects every semester. What we typically find is about a third of them choose a NASA project. So I think that's affirmation, and that's semester after semester. So I think that it builds up a lot of confidence that our students both think that the portfolio is useful and exciting and cool. And so we have a lot of data to support that. And what I'd love to do is also, so how we have the NASA folks engage with us is we have them introduce the portfolio, introduce the licensing aspect of what you can do for T2U, because this is very real for them. And with the CreateX opportunity, we like to say, if you really want to continue this, we can, talk to CreateX, get you into the program, you can interview to get in the program, and you can continue on this journey. So we make this a very real outcome, possible outcome for these teams. But where we started the journey is back in 22, Christy Funk reached out and connected with myself, and with her and along with Michaela, we were able to set up this program and work on how we connect together. And right now it's an embedded, seamlessly part of our class. And then what we do, as I mentioned it, for those teams that do choose it for the final project, we ask NASA to come back and provide feedback in our final presentations. And that's Katrina and Michael, who are the latest NASA members to come out. They do an amazing job. Michaela's always there to share that, hey, it's for us to run the class, and we very much run the class our way. But when NASA plugs in and they provide feedback, it's very consistent with the tools and the processes that we're teaching in our class. So it's complementary to what we do. So it's like having another instructor that knows a lot more about the NASA technology than we do. And so it's fantastic having them plug in. So to me, never had any downside with this, only upside, and appreciate all the support I've gotten from the team. So with that, let me kind of wrap up with the last couple things. Here's some examples, and these are just a portion of a final project presentation that it might have. There's some just overviews of what some of the teams might do. They have to reference the TOPS number, which is a reference number in that patent portfolio. But in this case, this is a microwave-based water decontamination system. They're suggesting that they can design one that's superior to the existing ones in homes, and that homeowners will use it. Here's one that's designed on the RoboGlove that NASA has released in the TOPS 37, where it can be used to lift heavy objects, potentially in industrial workers, to reduce safety potential accidents out there. And then another one based on this technology of basically a portable health tester. And the team came up with the name Puff, thought it was pretty creative. But they'll come up with these ideas. They'll do customer discovery, they do tests. We'll do some basic financials and validation, market size analysis, competitive analysis. And they'll end with the idea of, should we move forward with this project, or have we proven that we should not? So we reward our students and teams for deciding whichever outcome makes sense based upon the data that they've collected within the time frame that they've been given to collect that. Here's a couple quotes from our students. I think the number one takeaway for what we're teaching is, as an engineer, you typically don't talk about customers. You don't talk about user-centric customer experiences. You don't talk about how to get customer validation, but you are very good at processes as an engineer, and you are very good at validating or invalidating thesis and data. It's just we are dealing with human data or human feedback in this case. So it's trying to apply those processes using some of the engineering skills that we're really good at. But I love the fact that many of our students say, hey, this is simply pushing me out of my comfort zone. And that's the idea. By the time they're done, we believe that they've grown confident in their presentation skills to provide technical presentations, and certainly on the entrepreneurial side, gain confidence in some of the terminologies that are used out there in industry. And then let me just wrap up with this before we open up for some questions. As I mentioned before, about a third of our teams choose the NASA project, and I think that's because of the NASA brand. It's just simply cool. Our students love it, and they resonate with the different technical options that are covered in the patent portfolio, so they connect with those patents. Um, Almost all our students, as I mentioned, will either take a PhD path or work in industry before doing a startup. So with that said, we have to tailor our course with that understanding, because it is a required course. We get a lot of students that otherwise will say, hey, I'm not going to be an entrepreneur. I don't want to start my own business now. So we tailor our course and we make it a little more, we make it a little more geared for that entrepreneur approach to this course. And when we look at how we structure the course from a project perspective, what that implies is it's very difficult for us to want to run a single project for the entire course of the semester. It simply becomes very redundant and boring for some of our students who are otherwise not interested. So we've learned we have to do multiple projects, which does two things for us. It allows us to keep the students engaged better, and it allows us to have different experiences for each one of the projects. But it also allows us to rotate the students. As I mentioned to you before, many of our students have already gotten jobs at some of the companies that their peers in the class want to get to. So it gives them a chance to get to know more of the classes. And then at the end, for that final push, we let the teams self-select and self-select their projects. So with that, let me just wrap up with, here's my contact information. If anybody's interested in learning more about what we do at Georgia Tech, please send me an email. Happy to respond to you, and happy to answer any questions you might have.
Thanks, Greg. Great presentation. We will go ahead and jump into some questions. And to all attendees, feel free to continue to put questions in the chat while we're speaking, and we'll get to as many as we have time for. All right. First question, can you explain a little bit more about CreateX? Are all of the students who are in your class part of CreateX, or is that something they have to apply to get into?
Yeah, thank you for that question. CreateX is an application process. It's a competitive process. It's for any student at Georgia Tech, and it's for any alumni that has graduated from Georgia Tech. So it covers a wide base. So we have a lot of applications for a limited number of slots.
Thanks. How do you balance giving the students creative freedom in their projects while still focusing on evidence-based entrepreneurship practices?
Yeah, so we give them some boundaries for the ideation process. For instance, we say, hey, work within the NASA patent portfolio for this particular project. So it's pretty wide open, so they can be as creative as they'd like to be. And then in the discovery process, we narrow down into what it was your thesis, what are those hypotheses that you're trying to prove and collect data on. So really what I focus on is not, do I think the project's cool? That's really not what I do. I look at the thesis and hypothesis that surrounds their idea and said, did we collect the appropriate data? Did we talk to the right audience and customers to validate that thesis? And that's what the students are doing. So there's no, and we try to tell them to be creative in finding and identifying those people to interview or to do testing on. So we actually encourage them to be very creative. They just have to do it within the process parameters, and they're pretty wide open.
Thank you. Coming from an educator who doesn't have an entrepreneurial background, what advice would you have for incorporating technology entrepreneurship into a business course?
Yeah, I think without the background coverage, I think it's awesome to plug in something like a T2U program in NASA, because they provide that natural selection of patents and technical ideas for your students to go work on. I think one of your previous webinar guests had said, hey, they go through and they narrow down the search. You might want to narrow it down to areas that you're comfortable with the students presenting on. Because I think we're not experts in every technical area, and that's not the idea. But certainly, if you apply it in a business class, you don't have to be. You're just applying the processes and just trying to validate some of the data sets that are coming back in from that audience or those customer segments. And you just need to be comfortable with that. So I think it's natural to do for business students. They may feel uncomfortable with some of the technical stuff, but I think that's why you plug NASA in, because they can help bridge the gap of some uncomfortableness with the understanding the technology. And NASA does a great job too with those files that they have on in that website. They're very easy to read, and they're well written, and there's a lot of photographs that go along with explaining what you can use their patents for. So to me, it's an excellent opportunity to get some stuff done like that with NASA.
Mm-hmm. And real quick before I get to the next question, Mike or Greg, there is a question from Mike in the chat about whether or not this program is available to other universities. Yes, T2U is a NASA initiative that we do with universities and colleges around the country. Greg is speaking about his experience applying this at Georgia Tech and within his class there. So this is an example, but we do this across many other universities and colleges, and instructors are encouraged to reach out to us via the email that's on our website. We can put it in the chat box as well if you're interested in starting a program at your university. All right. Given your experience across both industry and academia, what skills or mindsets do you believe students should develop to successfully bridge the gap between the two?
That's a good question. In some cases, the businesses are different. Like the business of academia is very different than the business of industry. So for me, it's understanding what the metrics are, right? So for us at Georgia Tech, I mean, our job is to educate students and to provide them into the workforce for these amazing companies that then hire these students. So it's preparing them for the right skill sets. I think having the experience in industry allows me to understand what it is. I've hired a lot of engineers over my career, so I have the opportunity to reflect upon what I was looking for, what some of the organizations were looking for when they went out and hired people. So I think there's a lot we can learn from industry as to what we should tailor some of our educational materials towards, and that's kind of how we applied it at Georgia Tech within the class. We take some what we think are practical outcomes and desired outcomes that some of our corporations that are hiring our students will look for. And we try to prepare our students as best we can and give them some practice in very much a low risk environment, which is their studios, where they can practice some of the same skills that they'll be doing for some of the businesses that they work for.
Thank you. Let's see. Can you talk a little bit more about your journey with working with NASA Tech Transfer Office? What are some best practices for collaborating with industry partners to ensure students gain real-world experience while still meeting academic objectives?
Yeah, so I interpret that as a two-stage. What's it like working with NASA, and then what's it like working with other corporations? Michaela, have I interpreted that correctly in your opinion?
I think so. I think they're asking, yeah, what is it like working with NASA, kind of as an example of
Working.
bringing a third party into the classroom experience and bringing value to the students in that way?
Yeah, I mean, I think ultimately it's my responsibility to teach the class, and NASA and Michaela and the team there do a fantastic job of saying, "Hey, we're here to complement what you do in your program." So for me, it was when I was designing the course and because when I first inherited the course, we did not have T2U integrated into the program. So we sat together, discussed kind of the best ways to insert it and where does it make sense for us in the content and the cadence of our course. Where does it make sense to insert T2U? And we've evolved a little bit over the past few years and learned from that. But I think that's the mindset. I think you want to look at your course, understand where's the best way and the best application and the timing to introduce something like this, and then understand how you want to define it. Do you want it just to be early in your course where they run with this project over the semester, or do you want this to be introduced as saying, hey, now we're going to evaluate a technical project, and we're going to use the NASA portfolio as that technical projects that we evaluate, and we do that for a portion of time. So I think it really depends on what you're trying to do. Where we found out, as I mentioned to you, an entire semester of running with one project just didn't work for our students, primarily because of what they want to do. So we've found ways to plug them in for a period of a few weeks and then give them that optionality towards about the midway point of the semester to run with the ideas that they had worked on previously. And I think it works really well to give them that range of freedom.
Thank you. Let's see. Do you find students tend to gravitate towards similar technology, or is there a pretty wide range of interest areas?
Each semester, we tend to get a few of the same NASA portfolio technology projects. So they certainly gravitate, which may be a reflection of it truly is a pain point if students continuously bring it up. Um, I don't know how much they communicate with each other from semester to semester, say, hey, you should do this. But every semester, I'm blown away by the creativity and the innovationness of the students coming up with novel ways to apply something. I mean, whether it's approaching just a customer segment in a different way and looking at the customers and finding early adopters, the students really do make it their own project, and that's what we teach and coach. Really, it's not up to us to gauge whether it's a good idea. It's up to the customers. So where it goes is based upon the data they collect, and the outcomes differ for the majority of our students. So even if they have a similar project, the outcomes tend to be different, and the journey tends to be a little different sometimes. And so it's just because the team thinks differently and has a different hypothesis and thesis that they're trying to validate or invalidate. So we don't worry too much about having projects, the same projects. Again, from my experience, we typically see that they end up in different places.
Thank you. We'll go ahead and round out with a question that we like to ask everybody who comes on the webinar series, which is if you could offer one piece of advice, in this case, it would be to an instructor who's interested in bringing this into their classroom, what would that be?
Definitely do it because, again, when you ask students and you see the reaction when NASA gets on our engagement calls to talk about what they're doing at NASA, all the heads raise, right? So for me as a lecturer, I get the head bob, right? I can tell when I'm losing my audience. I can tell when they're engaged. When NASA comes on, these students are engaged. And for me, it's a rewarding experience to know that when we're bringing in guests or we're bringing in concepts or programs like this, is it interesting to our students? And you can certainly see that. And I think that goes back to the brand. I think NASA is just very cool. And what they do with T2U makes it easy for us as instructors to integrate them into our classroom. So I think for ease, for the brand, for the student engagement, I think there's a lot of reasons to pull the T2U program into your course.
All right. Thank you so much, Greg. We appreciate your time. I hope everybody enjoyed this edition of the T2U Innovation Series and enjoyed hearing from Greg about how he uses NASA technology in the classroom. Our tech transfer website is up on the screen, as is our email if you're interested in getting in touch. I hope everybody has a great rest of their day. Thank you for coming.